And welcome to lesson 5.3, and we're talking about parallel lines here. And the first thing it says to draw two parallel lines below, make them big and fairly far apart. So those are my lines in blue that I wrote already, and it says label them L1 and L2. So I'll just write that in, L1 and L2. And then down below there's a question. It says, how do you know when lines are parallel? Well, there's more than one answer to this, but one way to say it is that those blue lines are parallel if they're going the exact same direction, or if they're never going to meet. I wrote little arrowheads on the ends of them to show that, lines, we can think of them. If they go off forever and ever, those blue lines are going to be perfectly parallel if they never meet. But I think I'll just put like same direction, because I think that's what most people would say, same direction. Okay, now the next thing is a transversal. What does trans mean? So trans, like the Trans-Canada Highway, means like across Canada. So a transversal means across. So I drew one in green, and it says down here, over here it says draw a transversal above. So I did that already. A transversal is a line that cuts across the parallel lines, and I'm going to write parallel like that. Two lines that are parallel, the parallel lines. Okay, so there are four terms that we're going to learn this lesson. Opposite angles, or more fully, sometimes people say vertically opposite angles. So you'll hear me sometimes say vertically opposite angles, sometimes I'll just say opposite angles, and I mean the same thing. And then there's three others as well that we'll get to. So the first one is opposite angles, and we're going to go to the next page for that. And looking at the diagram over here, I would say that 70 degrees and x are opposite of each other. So another way, it says on the page, it says angle x is vertically opposite of the 70-degree angle. Well, before we get to that, here's a question. How many degrees in a straight angle? So remember, a straight angle, makes a straight line, and the number of degrees is 180 degrees. So I'm going to write 180 degrees. How many degrees in angle y? And there's sort of a hint there. It says 180 minus 70, because we can think of this whole section here, or if I draw it like this, we can think of this whole angle as a straight angle. So that would be 180 degrees. And if the top part is 70, that means that y is going to be 180 minus 70, which works out to 110 degrees. So in other words, here I'll erase my other stuff here. In other words, we just figured out that this must be 110 degrees because 110 and 70 add up to 180, and this makes up a straight line. Okay, so our next step is, what about angle x? Angle x is making a straight angle with y. These two together, added together, make this straight line. So in other words, x has to, when added with 110, x is going to be equal to 180. So I guess the question now is, what's 180 minus 110? And we're back to that 70 degrees. So this is kind of a proof. This is sort of logically thinking about the numbers here, and we can make up a rule, and we can say whenever we have these opposite angles, in this case the 70 and the x, we can say that they're going to be the same number of degrees. So if the top one is 70 degrees, then that bottom one is 70 degrees. Draw two more lines that intersect. Show which angles are vertically opposite. So I'll draw this one and this one. I'm just going to estimate, maybe say this one is 40 degrees here. If the top one's 40 degrees, then this bottom one is also 40 degrees. Also, if this one is 140 degrees, then this one's going to be 140 degrees. So we say vertically opposite angles, but really when I'm taking two lines, they don't have to be lined up vertically. They can just be any time there's opposite angles. So a short way to show that those are equal is just to put a single equality mark on both of those. So those are equal angles. Okay, so that's the first of the four things that we learned, is about opposite angles. So whenever we have two lines that intersect, angles that are across from each other are going to be equal. Okay, our next one that we're going to talk about, oh, actually before we get to the next one, we have to talk about what are corresponding angles. So corresponding angles are like the similar angles when we have more than one intersection. So in this case we have two different intersections. I'll call it the yellow intersection, and I'm coloring this one the blue intersection. And so angle 1 occupies that spot in the yellow intersection. Which angle occupies the same spot in the blue intersection? It's angle 4. Okay, so those two are corresponding. So I could write here, oh, actually I kind of jumped the gun here a little bit. It says label either parallel or non-parallel. So I think these two lines are parallel. Just looking at L1 and L2, it looks like they're going the same direction. If I look at the other one over here, those do not look parallel because they're not quite the same direction. All right, so now when we talk about corresponding angles, what's the definition of what I was talking about earlier? Corresponding angles are in the same position but different intersections. So for example, angle 1, and angle 4 are corresponding. Okay, so let's take a look at these, angle 1 and angle 4. Do those look like they're about the same angle? I think they do, don't they? Like if you look at angle 1 and how much the angle, how much between here and here, the angle of those two, and then angle 4, when the two lines are parallel, it looks to me like the corresponding angles are equal. How about if I go over here? Let's look at similar ones. Let's look at 6 and 2. Those are corresponding. Are 6 and 2, are those two angles equal? No, they're not. So we're going to make a rule here. We can say, when are corresponding angles equal? When the lines are parallel. I'm going to look at this one here and let's talk about other corresponding angles. If I've got angle 1 here, what's the corresponding angle in the other intersection? 5. Okay, I'll pick a different color here. If I've got angle, say 7 on this one, what's the corresponding angle on the other intersection? 3. Okay, if the lines were equal, then those correspond. If the lines were parallel, then the corresponding angles would be equal. Okay, so now we've covered two of the things. I'm just going to back up. We've covered opposite angles are equal, and when the lines are parallel, corresponding angles are equal. Okay, so we've learned a couple things about angles. Next, we're going to talk about alternate interior angles. So interior means sort of on the inside of the parallel lines. So kind of like that. That would be interior. Alternate means like every other. So on different sides of. Alternate means, think alternate days, sort of every other. Hope that makes sense. So in this case, let me see. Alternate interior angles. Here would be one example. Angle 3 is an interior angle. And an alternate interior means on the other side of the transversal. So in this case, means other side of transversal. So this is the transversal. So if 3 is on one side of the transversal, what's an angle that is still an interior angle, still in the yellow zone, but is on the other side of the transversal? It's over there. So angle 3 and angle 4 are alternate interior angles. Which pair of angles are alternate interior angles? Angle 3 and angle 4. If the lines are parallel, then alternate angles are equal. Are these lines parallel? No. Are angle 3 and angle 4 equal? No. So in this case, not parallel lines. So angle 3 is not equal to angle 4. What if I added a number here? Which number is missing? 8. If I put 8 here, which angle is an alternate interior angle to angle 8? So if I have angle 8 here, the other one is on the other side of the transversal, but still in the interior, still in the yellow zone, angle 7 is also an alternate interior. So I'm going to put over here angle 7, and angle 8 is another pair of alternate interior angles. Oh, we're almost there. Alternate exterior. Okay, so just a reminder that interior is between the parallel lines. So it's the parallel lines are going different directions, so it's a little bit harder to tell. So this is the interior. And the exterior, I'm going to highlight in blue, is over here. That's all exterior. So alternate exterior lines are both in the blue zone, but still they alternate, in which case they're on alternate sides of this transversal. So let's pick some alternate exterior angles. So if I pick angle 2, it's definitely an exterior angle, and the alternate exterior pair with it is angle 8. So angle 2 and angle 8. What's another pair? Well, I'll pick a different color here. Angle 4 and angle 7. So you see they're quite far apart. They're both in the blue zone, but on the opposite blue zone and on the other side of that line that cuts across the parallel lines. So the other one was angle 4 and angle 7. Those pairs are alternate exterior angles. Are the lines parallel in this case? Yes, which means that those are equal. Which pairs of angles are alternate exterior angles? Oh, I guess that's what I did here. Which pairs of angles are alternate interior angles? Angle 1 and 5. Angle 3 and angle 6. Name at least two pairs of corresponding angles. Well, I could say angle 4 and angle 1. And I could say maybe angle 5 I'll pick, and angle 7. Name at least two pairs of opposite angles. So I could say angle 4 and angle 5. They're opposite of each other. And maybe angle 6 and angle 8. Whew, lots of things. Okay, so that's the end of the lesson. I'm just taking a look at the worksheet here. So in the worksheet, I create something that I call a statement reason table. And so when you're doing this on your own, you can make a table just as quickly as going like this and writing an S for statement and R for reason. So S for statement is like what you want to say, what you want to prove, and R is why you know it's true, the reason why you know this is right. So the first statement, it says that angle 1 is equal to angle 4, so I know that angle 1 is 122 degrees. It's kind of like two little statements in one. How do you know that angle 1 is 122 degrees? Well, here are all the reasons that you could use up to this point. We know that a straight angle is 180 degrees. That's something that we can use as a reason. We know that opposite angles are equal, corresponding angles are equal, alternate interior angles are equal, and alternate exterior angles are equal. And those last three are when lines are parallel. So angle 1 and angle 4, it seems to me, are corresponding angles. So my reason here, I could write it out. I could write corresponding, maybe I'll just core for corresponding angles. I can write like this. Angles are equal. I could just say equal. There's a really short form. Or if you were really because I wrote that list and I put letters beside it, you could use C as well, because here it is for C. Corresponding angles are equal. Let's look at the second statement. The second statement says angle 2 and angle 4 add up to 180 degrees. So angle 2 is equal to, so it's trying to figure out over here, these two. Well, those two make up a straight angle, so that's why they add up to 180 degrees. So if I know one angle, the other one I do 180 minus it. So let me just think over here, 180 minus 122. If I get my calculator out, I think it's 58. Oh, you know, I just realized I'm doing your worksheet for you. So then you kind of figure out, so this would be 58 degrees. And then so write in the reason over there. In the next part, here is a reason. Opposite angles are equal. See if you can pick a reason, or see if you can pick a statement. Pick two opposite angles that are opposite. And maybe, you know what, how about this one? I could pick an 8 here. What's angle 8? How do you know? And then these last two are, you can pick your own. Make up your own. Just say, hey, I know what angle 5 is, or I know what angle 6 is, and tell me why. Oh, and the other thing is, once you've figured something out, like we figured out that angle 1 is 122 degrees, so you can actually write that in over here, because we've proved it now. So this is 122 degrees. So you can use that. And we figured out that this one was 58 degrees. So you can use it afterwards. So angle 2 and angle 6 are corresponding, for example. So one of your statements could be angle 6 equals 58 degrees, because I know it's corresponding with angle 2, and so on. And is that it for the worksheet? Yeah. Okay. Oh, there's a little bit more. State the value of the unknown angle and state the reason. I think I wrote this twice. Okay, good. So if you have any questions, please talk to me and we'll figure it out. Thanks.